Okay, here's some more Fibonacci problems. First one says 5 to the 9 is equal to a square root of 5 plus b. Solve for a and b. Okay, here you can pause button and then come back. Now, we're going to use the formula that the nth power of Fibonacci is equal to the nth power of the golden ratio is equal to 5 times the nth Fibonacci number plus the Fibonacci number of n minus 1. This was something that we did earlier, and I just want to check it to make sure it's right. Yeah, that's it already. Okay, that's good. Now, what that tells us is that 5 to the 9 is equal to 5 times the Fibonacci number of 9 plus the Fibonacci number of 8. So that makes things a lot easier. Now, the other thing that we're going to need to know here is how is the square root of 5 related to this golden ratio? Now, golden ratio is 1/2 plus the square root of 5 over 2. So we're going to put that in there. The ninth Fibonacci number is 34. And the 8th one is 21. So now we have to work on this a little bit. We want to get the 34 into here. That makes 17 plus 17 times the square root of 5 plus 21. That's equal to 17 square root of 5 plus 38. So the answer to this is that A is equal to 17, B is equal to 38. Okay, that was pretty hard. And you got to remember that formula. And you also have to remember what the formula is for the golden ratio. 1.618, but you need to know it in terms of the square root of 5. Okay, let's try the next one. 29c, what is that? Okay. This one says, solve the following quadratic equation. 3x squared equals 5x plus 8. Now you can hit the pause button. It says use a calculator to approximate the solution to 5 decimal places. 3x squared minus 5x minus 8 equals 0. Usually what I do on a problem like this is I first check to see whether I can factor it by myself. I try things like 3x, x, but I'm going to have to get a negative 8. So I'm going to have one of them's going to have a negative sign. One of them's going to have a plus sign. 8. That's like 4 and 2. If I multiply the 3 times the 4, I get 12. If I multiply the 3 times the 2, I get 6. I don't know if I'm going to be able to... 6 minus 4, I don't think I can get that negative 5 in there. Okay, so let's go right to the 8 times. Oh, hold on, wait. Also, I can do 8 and 1. So maybe if this was like this, 8 and 1, this might do it. You get the 3x squared, you get the negative 8. Now here's the cross term ooh. No, you want the 8 on here. Let's try it like this. That other cross term didn't work out. So I try it the other way. 3x squared, you get 8, you get negative 3, and a positive 8. That's positive 5. We want to get a negative 5. So we put the negative sign over here and make this positive. Okay, this looks like it's going to do it. We get 3x squared, we get negative 8, we get 3x and negative 8x, that makes negative 5. So this is a good factor. This is going to give us two solutions. X equals negative 1, and x equal to 8/3. That's it. I don't know why that's such a big deal. Now, the coefficients of this were Fibonacci's. That's the ratio of two Fibonacci's. That's just a -1. Of course, maybe they're trying to emphasize this one. This is actually the ratio of two Fibonacci's, but not consecutive Fibonacci's. So this ratio is actually approximating phi squared, but anyway, we solved the problem. Okay? Let's move on. Okay, next problem. From 39. Okay. So this problem says R is a rectangle with sides x and 3. This is a rectangle called R. And it says that R prime is a rectangle, and R prime is a rectangle which has sides x, 8 minus x, and 5. Now what they want is, what are the values of x that will make R and R prime similar? Well, for them to be similar, the ratio of the two sides has to be the same. So one way that can happen is if x over 3 is equal to 8 minus x over 5. Because that means that the ratio of this side to that side will be the ratio of that side to that side. They will definitely be similar. Okay? Now, this is probably not that complicated. We cross multiply. 5x. There's 24 minus 3x. Get the 3 on the other side. Get 8x over here. 24. We get x equals 3. X equals 3 is one of the answers. And when you look at that, it makes sense because this is a square. 3 by 3, and this is 5 by 5. They're both squares. Okay. Now, but that's not the only possibility. The other possibility is that x over 3 is equal to 5 over 8 minus x. In other words, this could be similar to that, only this would be rotated. That's why I made the ratio of this to this equal to the ratio of this side to that side, not that side. So, now this is a little bit more complicated because this will give you a quadratic equation. This gives you 8 minus x times x equal to 15. Or negative x squared plus 8x minus 15 equals 0. Or what I like to do is x squared minus 8x plus 15 equals 0. Like before, I like to try to factor it myself instead of using the quadratic, especially when these are integers that are small. So I kind of like this. This one I can see right off the bat. The only way to get 15 basically is 5 times 3, and 5 plus 3 is 8. So this one is going to be x minus 5, x minus 3. That's going to equal, that's going to do it. That's going to give x squared, it's going to give 15, it's going to give negative 5, negative 3. So there's two solutions here. One of them is x equals 5, the other one is x equals 3. X equals 3, well, already found that one. Now let's look at x equals 5. If x equals 5, this is a 5 by 3. And this is a 3 by 5. But of course, 3 by 5 and a 5 by 3 rectangle are both similar because one's just rotated version of another. Not only are they similar, those ones are actually identical, congruent. One's just rotated. They're the same actual size. Just the only thing that differs is a rotation. Okay. Now, let's go on to another problem. This one says, and this one looks like this. You have a problem like this. This side has a length of 9. And then it has a certain dimension, c. And then it's got another dimension. I'm sorry. This dimension is 3. And then this dimension is c. and then this is shaded. And then the problem is, find the value of C so that the shaded rectangle is a gnomon. So the white is 3 by 9, which is to say, the total figure has to be similar. Now, the way that the total figure will be similar, there's probably two ways for that to happen. One of them is the ratio of this one, 3 to 9. It's going to be the ratio of the total one, which is going to be 9 to 3 plus C. Okay? Yeah. And there'll be another possibility. Another possibility is that the ratio of 3 to 9 is equal to the ratio not of 9 to 3 plus C, but 3 plus C to 9. Okay, well, when you look at it that way, you can see right off the bat down here that this one's going to give you C equals 0. C equals 0, this gnomon doesn't exist. And that's not a very interesting answer. I don't think that's going to count. So I'm going to count that one off. And let's just solve the other one. To get this one to cross multiply, we get 9 plus 3C is equal to 81. 3C is equal to 81 minus 9. That's 72. C is equal to 1/3 of 72. What's that? 24 maybe? 24 times 3? 2, 1, 72. That's what it is. C is equal to 24. So C is 24. This becomes 9 by 27. That's in the ratio of 1 to 3. Just like 3 by 9 is a ratio of 1 to 3. So that does make this if C is 24, this is a gnomon to the 3 by 9 rectangle. Okay. Let's go on to another one. Problem 48. Find the value of x and y so that the shaded rectangle is a gnomon. Okay, so this one looks like this. 8, 4, 6. Then we have y, then we have x. Okay, now they say, find the value of x and y so that the shaded triangle is a gnomon to the white triangle. Okay, that means that the total one has to be similar for that one. Well, let's see, how's that going to work? If it's going to be similar, see, on this one, 8 is the longest side. Now, on this other one, I think this has to be the widest side, longest side, y plus 4. If that's really true. X. Seems reasonable. That's the way I would try it. Now there might be more than one value for x and y. It says find the values of x and y. I'm just going to start with this one. I'm going to say that if this is the longest side, if this is the longest side, then there's going to be a couple of ratios like I got to think about this one. So let's see. This is the long side. We need to get this to line up to that one. That would rotate this way. That means the 6 would actually be corresponding to the 8.